Welcome to the ftir.fun Infrared Learning Series. This episode Ep09 Infrared vs Raman. Both vibrational spectroscopy. What's the difference? Then close with the checklist. Next, introduction. The same molecule, two languages. Imagine the scenario. You walk into a lab with an unknown. Two instruments sit on the bench and stir infrared spectrometer and a Raman spectrometer. This is not a trivial question. Although infrared and Raman both probe molecular vibrations, they speak two completely different languages. Next, physical mechanism, absorption vs scattering. 1.1 Infrared absorption, drinking light directly. Infrared spectroscopy is based on the direct absorption of infrared photons by molecules. When polychromatic infrared radiation irradiates a sample, if the energy of a photon exactly matches the energy difference between two vibrational energy levels of the molecule eats that photon and jumps from the vibrational ground state to an excited state I-altion. Next, selection rules. Dipole moment vs polarizability. This is the most fundamental difference between infrared and TAP. 2.1 Infrared selection rule. Dipole moment change. Next, IN. Rule of mutual exclusion, a dividing line for molecules to the center of symmetry. 3.1 Statement of the rule. Ep03 briefly introduced the rule of mutual exclusion. Here we delve deeper from a group theory perspective. Next, IV instrument comparison. Different weapons. 5.1 Stir instrument components. Modern infrared spectrometers almost exclusively employ Fourier transform infrared stir technology, Analytical components. Next, complementary information. What IR excels at? What Raman excels at? 5.1 Physical origin of complementarity. Since IR and Raman follow different selection rules, change in dipole moment vs change in polarizability. They provide complementary molecular vibrational information. Next, advantages and disadvantages comparison. Each has its strength. 6.1 Advantages of Raman spectroscopy. Oriba, Chinese official website, summarizes the advantages of. Next, fluorescence vs water, respective nemesis. 7.1 Fluorescence, the biggest enemy of Raman. Fluorescence interference is the most serious practical problem in Raman spectroscopy. The fluorescence signal is several orders of magnitude stronger than the Raman scattering, often completely overwhelming the Raman peaks. Next, spatial resolution. Where does the gap come from? 8.1 Diffraction limit determines the fundamental difference. Spatial resolution is determined by the Rayleigh criteria. Next, Analytical complementary application cases. 9.1 Art and artifact identification. Professor Robin J. HBE. Next, selection guide, which technique for which sample. Based on the above analysis, a practical selection guide can be special scenarios, carbon materials, graphene, CNT, diamond, Raman exclusive advantage in organic pigments, minerals, Raman are rich libraries, non-destructive drug polymorphs IR, Raman complementary biological tissues, live cells, Raman, water-friendly, high-resolution, forensic science, non-destructive, Raman preferred large area, coatings, tissue, sections, IR microimaging quantitative analysis, functional group content, Sir Beer-Lambert law, well-established gas analysis, sure, gas cell, IR, sensitive to small molecules. Next, advanced versions of Raman spectroscopy. After decades of development, Raman spectroscopy has spawned several enhanced techniques. Table 14 Derivative techniques of Raman spectroscopy. Source cancers. Next is the symmetric stretching vibration of water, both air active and Raman active. Why? If you have a bottle of colorless liquid suspected to be benzene or cyclohexane, can you distinguish them using only IR? What if you add Raman? Finally, the drill actualists. Make sure you can recall each item. Core knowledge points. Infrared spectroscopy. Physical mechanism. Photon absorption. Selection rule. Change in dipole moment q not equal 0. Light source. Broadband, mid-infrared source, global, detector. DTG SMCT. Strength, polar functional groups, equals OSS. NH. Water interference. Severe. Fluorescence interference. Non-spatial resolution. 10 micrometers. Sample preparation. Often required. Spectral library size. Hundreds of thousands. Mutual exclusion rule. Molecules with centrosimetry. Active Raman. Inactive. That covers the required sample for this episode. Practice with real spectra on ftir.fun and continue with the next lesson.